Hi there. Today's lesson is the continuation of our previous lesson, which is about independent events. This time, the focus is going to be about dependent events and then multiplication rule number two. So we will be using that. Let's have a recap of what do we mean by independent events. Two events A and B are said to be independent if the fact that event A occurs does not affect the probability that event B occurs. So independent events are not affected by previous events. Dependent events, which is the focus of our lesson today, on the other hand, are two events that if the fact that event A occurs affect the probability that event B occurs. So dependent events are affected by previous events. All right, let me give you an illustration here. This is the diagram, a guide that will help you identify if a certain event is independent and dependent. You ask yourself, is it possible for the events to happen in any order? If the answer is no, dependent. If the answer is yes, does one event that the answer is yes, then you need to ask another question. Does one event in any way affect the outcome of another event? If the answer is no, that's independent. If the answer is yes, then that is dependent. All right. So let me give you an illustration here. A bag contains 8 red marbles and 4 blue marbles. You randomly picked a marble and then picked a second marble without returning the marbles to the bag. So these are the words that will give you an idea if an event is an example of dependent. The word without or the words without returning. That gives you an idea that we're talking about dependent events. And on the other hand, if this example right here, a cooler contains 10 bottles of sports drink, 4 lemon lime flavored, 3 orange flavored, and 3 fruit punch flavored. 3 times you randomly grab a bottle, return the bottle to the cooler, and then mixed up the bottles. So here the key word is the word return. So when you return something that you already picked, that means we're talking about independent events because here the denominator is not going to change. For dependent events, when you picked one, so let's say you picked one, let's say there are 8, or here in this case, there are 12 marbles together. So you pick one, the denominator is 12. The second event, the denominator will be 11. So that event is affected by the previous event. All right. Now, in multiplication number 2, to find the probability of dependent events A and B, we just need to multiply probability A times the probability of event B. Okay? Given the fact that there is, we're going to subtract the number of possible outcomes in the second event. Okay, let me give you 5 examples here. Here we go. The first one. A box contains 24 toasters, 3 of which are defective. If 2 toasters are selected and tested, find the probability that both are defective. So, 2 toasters are selected. So, let's say here, first, second. So, first try, second try. On the first try, the probability of getting a defective is 3 over 24. Why is that? Because there are 3 defectives and there are 24 toasters. That's the probability. And here, you don't see the word return. Okay, and also you don't see the word without returning. If that's the case, then you will consider this as a case of dependent. That means you're not going to return the first toaster that you picked. Okay? So the second will be, the denominator for the second one will be 23 now because you already picked one. And also the probability or the number of desired outcome in the second is gonna go down to 1 or to 2 rather because you will subtract 1 from the 3. So 3 minus 1, you pick 1, that's 2. Since you already picked 1, you subtract also 1 from the denominator and now you have 23. And just multiply this 2 and it will give us the answer. So, but I think we can simplify this. We can simplify 3 and 24, that's 1 over 8. And we can simplify 2 and 8, that gives us 1 over 4. So 1 times 1 is 1, 8 times 23 is equal to 92. So it's a good idea to simplify first everything and then multiply it. But if you don't know how to simplify fractions, you might as well just multiply 3 times 2 and that gives you 6, 24 times 23, that will give you that answer, and then simplify it because we want to make sure that the answer is in simplified form. Another example, 2 cards are drawn without replacement from a deck of 52 cards. Find the probability that both are queens. All right. So, question, how many queens are there in a regular deck of cards? That is right, there are 4. The Queen of Hearts, Queen of Jacks, the Clover, and then the Spade, right? So, 4 queens. And then you're going to pick 2 cards. So, first pick, second pick. On the first pick, you have 4 over 52. That's the probability. Now here, you see the words without replacement. So that means on the second try, you're going to subtract 1 from 4. That gives you 3. Subtract 1 from 52. That gives you 51. All right, let's simplify first the numbers here. I think we can simplify 3 and 51. That gives us 1 over 17. And also, I think we can simplify 4 and 52. That gives us 1 over 13. 1 times 1 is 1. 13 times 17 is 221. That's the answer. All right. Okay, let me give you another example. A box contains 3 orange balls, 3 yellow balls, and 2 red balls. 3 balls are selected without replacement. And again, you see again those words without replacement. We will select 3 this time. So first selection, second selection, third selection. Find the probability of selecting 2 yellow balls and a red ball. So let's say we want yellow here, yellow on the second, and we want red on the third. Okay? So on the first try, how many yellow do we have here? We have 3, right? So that's 3 over, and how many balls do we have here in total? So 3 plus 2 is 5 plus 3 is equal to 8. So that's 3 over 8. On the second try, we want another yellow. So that means 3 minus 1, that's 2 without replacement. 8 minus 1 is equal to 7 times. This time we want a red ball. How many red balls do we have here? We have 2. Now the denominator will still decrease by 1 because we already picked 2. So 7 minus 1 is 6. There you go, and just multiply these numbers. But I think we can simplify 2 rather, and 6. That's 1 over 3. Right? We can cross out this 3 right here and there. This 2 is 1, and this one is number 4. 1 times 1 is 1 in the numerator. 4 times 7 is equal to 28. So it's easier to multiply everything if we can simplify it first, right? So 1 over 28 is the answer. Let's go to another example. In a study, there are 8 guinea pigs, 5 are gray, and 3 are brown. If 2 pigs are selected without replacement, and again, you see those 2 words, without replacement, or that phrase, find the probability of selecting a brown and a gray. Brown and a gray. So first brown and then gray. How many brown guinea pigs are here? There are 3. Total of how many guinea pigs? So 8 guinea pigs and then 5. That's a total of 13. No. There are 8 guinea pigs in total. So 3 over 8. 5 are gray and 3 are brown. Okay. Times. Okay, this time we want a green. So that means it's 5. But the denominator will decrease by 1. 7. Okay. So this is equal to, and I think we can't simplify this. So just multiply 3 times 5. That's 15. and then multiply 8 times 7, and that is equal to 56. There you go. That's the answer for this one. Okay. All right, let's go to the last one. In a classroom, there are 8 freshmen and 6 sophomores. So in total, we have 14 students. Okay, 14 students. If 3 students are selected, so student 1, student 2, student 3, at random for class project, find the probability that all 3 are freshmen. So the focus here is freshmen. On the first pick, we have 8 over 14. Why 8? Because there are 8 freshmen here. And then you subtract 1 from that 8, that gives you 7. Subtract 1 from 14, that gives you 13. Subtract 1 from 7, that gives you 6. Subtract 1 from 13, that gives you 12. All right. Now, I think we can simplify 6 and 12. 1/2. I think we can simplify 7 and 14. That's 1/2 as well. And I think we can simplify, this is 2 times 2, which is 4, and this is 8, right? 8 divided by 4 is equal to 2. Okay. And now we can multiply 2 times 1 times 1, that gives us 2. 13 is the only number that's left in the denominator. So 2 over 13 is the answer. So there you go. These are examples of dependent events. All right. Thank you for watching, and I hope you learned something.